Okay, great. Hello, everybody. So I think I must know about half the people locally, but I'm Titus Brown, and I am a professor here at UC Davis, and my lab uses Amazon Web Services quite a bit. So what I'm going to do today is take the opportunity to walk you through spinning up a new instance, doing some interesting things on the new Amazon machine, and then walk through various things that you can do, including renting hard drives, storing data persistently, sharing data, sharing configurations, and other such things, including also scaling up and down machine size and other ways that we've been using Amazon Web Services for a while. So this is a broadcast tutorial. So we have a remote classroom up in Vancouver, and they will be communicating with us via this Etherpad. And I'll show you the link for this Etherpad. For the local people, this is where we'll post stuff if we need to do copy-paste. We can type stuff in here, and then it'll show up on your screen, and you can copy and paste it from there. And it's also a place where they will ask questions and so on. And I think Jessica will monitor.
Yep.
Will monitor that. In part because this is broadcast, this will all be recorded, so it's going to be available on YouTube after the workshop is over. So
now and after.
Now and after the workshop is over, and so that means that while you should definitely ask questions, you can also have the opportunity, while I'm up here, you can also take the opportunity to note down areas that you want to go over yourself again during the breaks, and actually go back and rewatch the video more or less in real time. Okay, so where we're going to start is at this page. This is the workshop page that you should all have a link to, and it's Amazon Web Services. It has the information on it. The watch lesson here is to the YouTube link. If you're in the room, you don't need to click on this. And the materials is the important bit. So click on materials, and what you'll do is you'll come to this website, the main page for this tutorial. This page will also be essentially available forever, so we don't have any plans to take it down. Go ahead. Yeah.
Where do you get the link for that website?
So the link is under materials on
the page that you registered.
Or that page, how's it?
That page is under DIB training. So if you go to the DIB training website here, you can actually just Google. So I'll show you. If you do DIB training and you Google it, you should come up to the first hit for DIB training should be this page, and then on that page it's the top upcoming workshop here, and then it's the materials link on that page. Okay. And so this materials page will be up indefinitely. We won't necessarily update it, however. What we'll do instead of updating this page is run new workshops, link those into that workshop page, and then there will be a new URL here rather than February AWS. It'll be 2017 March AWS or whatever it is. I guess it's technically March now, but I created the repository in February. Okay, and then this is where you can go to the workshop Etherpad, as well as see all of the different lessons and tutorials that we have under this page. Okay. So before we get started, are there any upfront questions or comments? Is everybody on this page? Okay. Just flag down. There should be TAs both here. Jessica's the one here, and remotely. So just flag someone down if you need help with something that's on your screen. All right. Okay. So was there anything I've forgotten to say, Jessica?
I think we're good.
Yeah. Okay. So what we're going to do is we're going to start with walking through starting up a computer on Amazon Web Services, and then configuring it and running RStudio server on it. So this is a way to run an RStudio program on a computer that may be much larger than your laptop in terms of compute resources, or that may have more. You may want to run it on a remote computer so you can use your laptop for other purposes while the compute's running. And in some sense, it's a demo because it's just one of the many things you can do. Anything you can do with a remote Unix machine or a remote Windows machine, you can do with with an Amazon Web Services computer. But we have to start with something, and RStudio server seemed like a good something that a lot of people in the audience would at least appreciate. And I can we run almost all of our tutorials for bioinformatics on Amazon Web Services. So we have a lot of other tutorials, but a lot of them aren't as visual or visceral as having an R session up in front of you. So okay, so what I've done for the initial tutorial is I've actually created screenshots of everything. And so if you click on the Start an Amazon Web Services Computer tutorial, there are a bunch of thumbnails. And I'm not actually going to click on the thumbnails up here because I'll be doing it live. But if you ever get stuck and you're wondering what I just clicked, you can either flag me down, ask a TA, or click on the thumbnail, and what you'll see is a red box around all the things that you need to pay attention to. And again, these will be persistent. So if you ever get stuck, we've tried to make this as close to a sort of step-by-step walkthrough of everything involved as possible. Okay.
Louise can also answer your questions.
Okay, so so one other note: in order to display my screen in such a way that other people can see it, I have to zoom in a lot. I have to have a really large font size on my screen. So my screen is actually going to look different than yours because buttons will be hidden off to the side and stuff. So there's no real way around that. I'll try to remember to zoom out and zoom back in to show you where things are. So to get started, go to aws.amazon.com. Click on Sign into the console. And it should give you a sign-in box, and I'm going to sign in here. And this will bring you to the Amazon Web Services console. And the console has links to all of the different services that Amazon Web Services offers, most of which we're not going to talk about today. We're really only going to talk about the EC2 service, which stands for Elastic Cloud Computing. And that is that's the service that lets you rent computers and hard drives on an hourly basis, in effect. Before we click on anything else, come over to some of the things that we're doing are tied to a particular region, it's called, in Amazon. And so if you look over in the upper right, you should have a North California up there. And if you don't, the people up in Vancouver may have US West Oregon. Switch it to US West North California. It's because the operating system that we're going to be using, the specific details are the Northern California zone. The thing's also available in other zones, but under different names. I can show you how to find it later, but for the purposes of getting everybody on the same page, so to speak, we all want to start with North California. So, so what these different regions are different buildings, basically, or collections of buildings at this point. So different, there's some were server farms. So, I don't actually always know if like the North California one is actually located in California, but it's definitely sort of proximal to California. And the only reason it's important, so they use it to sort of load balance so that they can load balance and also deal with things like storms. So one of my favorite stories is watching about Amazon Web Services, being at a conference before the East Coast hurricane a couple years back, the one that flooded New York City, and watching the the Amazon Web Services guy who'd come to talk at the conference, sitting over in a corner on Michigan campus, shutting down all the services in Virginia and moving them to the West Coast. Because there was going to be a hurricane, so power might go out or flooding might occur or whatever, so they wanted to minimize the reliance on that machinery. So that's pretty cool. Anyway, so these server farms, generally it's not going to matter to you if one's hit by, if like Virginia is wiped out by a meteor. Yeah, your compute's probably going to go down, but that's probably not going to be really the first thing on your mind. So it doesn't really matter. The other reason you might care, and this is specific to Davis, is that, and maybe I don't know what SFU has, Simon Fraser University has, or the others, but is that you may have specific what are called interconnects that make it cheap or free to send data to specific regions. So I believe Davis, as of now, or as of a couple weeks back, has a free interconnect. Well, it's not free to Davis, but it's free for us now that Davis has bought it. Okay, it's cheap.
It's much cheaper than usual.
It's cheaper than usual to transfer large amounts of data to specific regions. And that's something you need to figure out from your local IT services folk. But in practice, at the scale at which individual users use this service, these issues are not likely to matter that much. I actually have most of my resources in US East because that's where I was until a year ago. It doesn't really matter where they are. It's just you can't use certain things from outside the zone or outside the region that you're in. There's a further zone thing that we'll get to when we start talking about connecting disks to instances. That's going to be further. Okay, so everybody should have US West, North California. And if you don't, the fourth or fifth step in starting up an EC2 instance will not work for you. You'll have to find a different name, and we'll cross that bridge when we come to it. So click on EC2, and you'll now come up with the EC2 management console. So this is the specific set of services that Amazon offers around elastic cloud computing. And there's a lot of stuff on the left, and we're actually going to go through about half of them, one way or the other, maybe a third of them, one way or the other. But rather than going through and confusing the heck out of you by describing all of the different options, we're just going to do something, and then you'll see how some of the pieces fit together. So all of you should have something that looks approximately like this. The real people can't see me when I walk around, but I'll just say that you should have zeros up and down the running instances, the dedicated hosts, the volumes, the key pairs, and so on and so forth. As long as you have zeros everywhere here, as long as you have zeros in running instances, dedicated hosts, volumes, and snapshots, you're not paying anything for your EC2 use. So if you come to this page and there's 0 in instances, volumes, and snapshots, then you're probably not spending any money at all. So it is they don't charge you a subscription fee. There's no ongoing costs other than the resources that you have running and are using right now. So if you walk out of here and you never use Amazon Web Services again, as long as you make sure that you shut everything down when you walk out of here, we're happy to take a look at your screen, help you with that. You won't get charged. I have had faculty members walk out and then 2 months later realize that they've spent like $200 a month on Amazon Web Services because they left something running. And they thought, oh, my partner's buying books on Amazon, or I'm buying books on it, that's why it's showing up on the credit card. Amazon can tell sometimes if you're actually using the resource or not, so they might refund it, but they're under no obligation to do so, so don't play that game. Okay, did you have any questions? Okay. Okay, so what we're going to do is we're going to start by launching an instance. And that's this big blue button right here. And if you click on Launch Instance, you'll come up with choose an Amazon machine image. We can go through AMIs, Amazon machine images, at more length later. We'll actually be creating our own in a little bit. But for now, just think of this as the operating system. For those of you that remember the days of physical media where you like put a disk in a computer and turn on the computer and then it started up whatever was on the disk, this is essentially the disk that you're putting in the computer or the operating system that you're installing. We're not actually going to use the ones that are on this front page. We're going to go over to community AMIs. We're going to start up at Ubuntu one. Yes, go ahead.
Why are we using this community one instead of one of these more common LTS?
So you have an interesting, so the question was, why are we using a community one rather than one of these more common ones? So if you hadn't slipped the word common in, it would be a different question. So the first answer is that these ones on the front page are ones that are sort of, they've chosen to, I don't know if they support them specifically or what, but they're stable ones. And this Ubuntu Server 14.04 is the one that I normally use, but it's from actually 2014. And when you update the software catalogs and install some of the newer software, 2014 in computer time was a long time ago, and so it would just take us longer. So I used to do everything on Ubuntu 14.04, and I still do for bioinformatics tools, but for today, with installing the RStudio server, it turns out to be a lot faster to use basically a newer version. And I don't know that these are actually that commonly used, because as you'll be able to see, we actually you can create your own AMIs however you want, and the big operating system vendors, Red Hat and Debian, actually, and Ubuntu, make their own operating systems available here on a regular basis, and that's actually what community AMIs often are. So something to keep in mind. Okay, so click over to community AMIs, and here I'm actually going to go back to the to copy and paste this AMI string. So this AMI string is a unique identifier. I think it's across all the zones, all the regions, but I'm not sure. It's a unique identifier for the thing that we're going to be running today. And when you click on it, you'll see that when you paste it in, you should see one match, and the match is this really annoying, obnoxious string, Ubuntu images, HVM, Ubuntu Wiley 15.10.amd64 server. And for people used to working with Unix, this gives you a lot of information. Basically, it tells you that this is an Ubuntu release from October 2015 that runs on 64-bit AMD machines, basically, which is what Amazon Web Services provides. And the way I found this was I actually just searched for Ubuntu and looked for the latest date and picked that date, and then made sure it worked. Okay, so click on Select. And the next thing, and this is both confusing and like the best, super, most awesome thing about Amazon Web Services, you get to pick the size of your machine, right? So the first question everybody has. So what I mean by size of machine is Amazon Web Services offers you many different kinds of machines. They offer you machines with 1 CPU. That's what this column is. 2 CPUs, 4 CPUs, or up to 40 CPUs. I think that's the biggest one. They offer you a lot of machines. They also offer you machines with this many gigabytes of memory. So half a gigabyte all the way up to, they constantly up it, but I think the biggest one there is 175 gigs. Or no, 244 gigs, right? Yep. And the machines also have different size, what are called instance or ephemeral storage, which is, the EBS only means nothing comes with it other than the basic operating system. But you can also get machines like an M3.large here, has a 32 gigabyte SSD hard drive. Why have I just forgotten what SSD stands for?
Solid state.
Solid state, thank you.
Wow. You're being recorded.
Because I'm being recorded, yes. There's a rule when you're teaching, your IQ drops by like 20 to 40 just for standing up in front of a group of people, and then when you're being recorded for posterity, it's like another 20 to 40 IQ points. So we'll see how this goes. So and so then there's the size of the disk. There's this, and I forget what column this is. There's EBS optimized available. Let's not worry about that. And there's also network performance. And network performance matters for a couple things. If you're going to be downloading large data sets, and I mean really large data sets, like multiple gigabytes on up, then this network performance kind of matters. But moderate and high are pretty good. The low ones you'll actually see, you'll be grabbing a big file, and it'll take like, why is this taking so long to download? Yeah, whatever. Okay. So what we're going to do, so the main question everybody asks is, how do I pick this, right? And the answer is it totally depends on what you're doing. If you want a laptop replacement, if you want something that's just going to run stuff about as fast as your laptop, I would go with like the T2 medium large or the M4.large. It's 2 CPUs, 8 gigabytes of RAM. It's basically about the equivalent of a pretty decent Mac laptop, not a super awesome one. If you need more memory, which is often why I come to AWS, because I don't have a lot of that, I only have 8 gigabytes of memory on my laptop, I might go up to 16 or 32. And I don't like this advice. There is no way a priori to know how much memory you need other than to run something and see if it crashes. There are ways to stop the instance, change how big it is, and reboot it. So you don't have to do anything other than like stop it and restart it, and you get more memory, and more disk space. But we'll go over that if people are interested. It's like a menu option to do it, which is pretty cool, I think. Okay, so for the purposes of right now, we're going to go with an M4.large, and then click on Review and Launch. There's a lot of things you can configure on Amazon. You can configure all sorts of things that we're not going to talk about necessarily. You can say how big your root hard drive is. You can link it to different network regions. You can assign it a static IP. There's lots of other things you can do. But for now, we're just going to get it started. Yeah, go, question?
Yeah, so because I'm still eligible for the free usage tier, I get this pop-up about
yes, thank you.
Magnetic versus SSD.
Yeah, so Amazon, as a way to lure you into using their service, offers for the first year you have an Amazon account, they'll offer you a very small compute instance for free. And anytime you deviate from sort of the really slow, boring default options for that, they'll charge you money, and that's what the warning is. That small instance isn't really that people use it for stuff, but it's not really useful for any data-intensive compute or anything. So that's why we're going for the M4.large.
I think this warning is actually different. It's saying the instance we have is selected with a magnetic volume, but
did you select M4.large?
I think so.
Yeah, Titus, that's happening to the first time people do it here as well. So you get the option of choosing magnetic, solid state drive, or
interesting. Okay.
So which one do you want them to pick?
It doesn't really matter.
Okay.
Okay, so we're going to go back down to review instance launch. And here there's all sorts of information that we can go through later in detail if people are interested. But let's start by just clicking on launch, all the way at the bottom right. Okay, and now you come to sort of the tricky, what I think is the real tricky bit, which is how do you log into these computers? So what Amazon doesn't do is give you a password to log into the computer. Instead, what it lets you do is use something called key pairs. And for those of you that use SSH a lot, you might have already seen something about key pairs in there. This is essentially using private key, public and private key infrastructure where Amazon creates a mathematical key and then gives you the secret, and they keep the public part of it, and they give you a private bit, and they don't actually keep the private bit. And so neither you nor anyone else can download the key again from Amazon. You get one chance to download it, and once it's downloaded, that's it. You can't download it again. So if you lose it, you lose access to everything that key had access to, and nobody can get it back. That's okay, because you can always just create a new key. But if you end up starting something up and then running it for a long time and then losing the key, your only real choice is to shut down what you were running and start up a new one. So what we're going to do, I just deleted all my key pairs. So we're going to create a new key pair. It's free to create key pairs. And I'm going to call mine Amazon key. And it's going to insist that I download the key pair so for all of you that haven't done this, the launch instance button should be grayed out. So it's going to insist that I download the key pair. So I'm going to click on download, and then I get an Amazon key.pm that gets put in my downloads folder. Go ahead.
So I guess I know a little bit about key pairs, and maybe I'm just understanding, but I have a public key, and I can't just give it to Amazon.
No. Yeah. There are ways, once you've created the computer, I can show you how to add your existing public keys to it. But for that, because what they have to do is they have to create a server and give you some way to log in. And I guess I don't think that I suppose in theory they could let you upload a key. Maybe there's even a way to upload it that I just haven't seen. But yeah.
I'm just making sure I was.
Yeah. In general, the sort of advice here is, people who gain access to your Amazon computer can do things on it, spending your money. I mean, they can't actually consume more of your money than you're already consuming by running it, but they can sort of divert your compute. So they're just sort of being secure about it. Also, there are companies that run everything off of Amazon, so they sort of are a little bit. I wouldn't say they're very security conscious in terms of doing these things. Okay, so you should have all downloaded the key pair. And then you now have a .pem file, and on Macs this PEM file is going to be in your downloads folder. On Windows, I don't know where it goes. Depends on the version and the browser you're using, but you need to be able to find it. So if you name it Amazon-key, it should be easy to find, and it should be easy to understand what it is when you come across it in 2 months and forget all about today. So you can name it whatever you want. You can create as many as you want, and you just have to pick which one you're going to use when you start up the computer. So click on Launch Instance. Okay, as of now, you're being charged. As of clicking Launch Instance, you're now being charged for your use of Amazon Web Services. And let's go click on View Instances. Let's go click on View Instances. And I did click on Launch, right? Why? Oh, I have a I have a weird screen. Okay. So all of you should have something that's either starting or running. In my case, it's this. It's the second one. The top one is something that I was testing some of the tutorial materials on earlier, and this is now your running Amazon computer.
Titus,
Tiffany.
we're having quite a big. Everyone pretty much in the room is having a bit of an issue where they haven't been verified yet, so they're not able to launch an instance. So in less than 2 hours. So can I maybe launch an instance and share it with everybody? Would that be a solution?
So verified, like.
If you just created your account this morning, it takes a couple hours to verify.
Really?
Okay. I did it at least an hour ago.
Did you verify it?
Oh. Okay.
Yeah.
So Tiffany, the problem is that without access to the console, they can't do most of the configuration.
Yeah. So like they're able to log into the console. They were able to select a machine, but they couldn't launch an instance.
Do you think they're able to launch a free tier instance?
Can they try launching a free tier instance?
Okay, can you guys try that? So instead of the MX4 large.
Yeah. Amazon somewhat regularly changes the rules, so I'm never entirely sure what new accounts are subject to.
Okay, let me just swap the screen. The free one works? Okay, the free one works, so I'm just going to show everybody
that should work for everything then, yeah.
Okay.
Yes.
So I've just switched to my screen for 1 second to show them.
Okay. Okay, so we'll just hang out here until we hear back, Tiffany, okay?
Sounds good. Okay, Titus, we're all good here.
All right, cool. So we were just talking about storage, which we'll go back over again in a bit. But okay, so you should all have one green running thing. You'll see that it's in US West 1, and then there's this C at the end, US West 1C. And that tells you the region, which is US West, and then the zone is the C, is the 1C. And when we, later on, when we attach persistent hard drives to it, you might have something other than 1C. It picks randomly if you don't specify. And when you add disks to it, you can only attach volumes or persistent disks to this instance that are in US West 1C. Because when they attach disks, it's all within, I view these things as sort of one buildings. I think they're probably bigger than, I think they're like probably massive warehouses at this point. But those zones are sort of where the computer that's running is and where the hard drives that you're trying to attach it are. I like to think of it as gnomes running around in a large warehouse, and the gnomes can't run too far when they go to retrieve a disk and bring it back and plug it into a computer. But of course, it's actually all software underneath. Okay, think of the gnomes basically. Okay, so what we're going to do next is log in, and this is where there's a split in the in what you have to do. If you have a Mac or a Unix computer or a Linux computer, you can use the command line to do it. If you have a Windows computer, you need to use the MOBA Xterm application. And I think in this room there's only one Windows computer, one or two Windows computers. So we can help you through the MOBA X. Are you running Linux? Okay, there's 0 Windows computers here. Tiffany, are there any? Oh, you're running Windows on a. Oh no, it's actually on a. It's not a Mac. It was gray. I thought it was a Mac. Okay, we can help you. We should just help you individually. I think Jessica or Louise can help you.
We have a couple Windows machines here too, yeah.
Okay, I'll run through the Windows screenshots and show you, but I don't have the Windows software installed on my Mac, so I can't actually run it. But in any case, the basic idea is what you need is this piece of information, which is the public DNS, which is this EC2 54.215.166.251. That's sort of the anonymous. It's like the just sort of an anonymous name that they've assigned to your new computer. It will be reused. So tomorrow, somebody else, when you shut down your computer, that name will be freed up for other people to use, and they can then use that. So every time you start up a new computer, you get a new name, basically. Okay? So you need that name, and then you need a terminal window if you're on a Mac or a Windows computer. And what you need to do is two things. This is on Mac or Linux, not on Windows. So does everybody know how to get to a terminal window? Okay, just flag us down if you need help. You need to find your key. So in this case, my key is in downloads, Amazon key.pem. And if you look at it, you'll see that it does not look like much of anything. It's an SSH. It's a private key. And what you need to do is pass that key into SSH. The way you do that is so you need to do two things. You need to change the permissions on it. If you look at this key, if you look at this key's, the file permissions on this key, you'll see that it's actually readable by others and by groups. That's what the thing, so it wants it to be only readable by you and not by these others. So to change that, you type changemod OG-RWX, the file name. This stuff is all on the in the tutorial. And if you look at it now, you'll see that the two R's have gone away. If you want to be an elite bro hacker, you can figure out what octal permission bits to set, but I don't care. Yeah. So anyway, I don't care. So. So the OG says others and groups. The -RWX says subtract, read, write, and execute permissions. It's a way to make sure that that file is only accessible by you. I have been using Unix for 30 years, and I don't remember the octal things once I figured out the OG whatever things. Okay. So now that you have this, you need to say SSH -I says use the identity in this key file. Use the username Ubuntu. -L Ubuntu says use the username Ubuntu, and then paste in. Do not type. Paste in the host name of your or IP address of your EC2 instance. Some of you may only have IP addresses. If it doesn't have an ec2 blah 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 .compute.amazonaws.com name, some of you will just have 4 numbers, and that you can put those. That's the IP address, and you can put those numbers in. Okay. Once you have this, you now hit enter. Okay. Quick thing. The reason we're using the username Ubuntu is because that's tied to the AMI that we used. The AMI, the operating system that we're using, is an Ubuntu operating system, and by convention, it's not required, but by convention on Amazon machine images, when there's an Ubuntu Amazon machine image, the default username that you use to log in is called Ubuntu. So you can, once you have an instance, it's your whole own Unix computer, you can create whatever usernames and whatever you want on it, but the default one that is tied to the key that you downloaded is actually only the Ubuntu. So you hit enter, and now it says, hey, you've never connected to this machine before. Are you sure you want to continue connecting? And of course you've never connected to this machine before because it was just created for you by Amazon. So you say yes, and then you wait a little bit. If you do this too quickly after you start the machine won't have finished booting. So you may have to wait up to a minute for after the thing turns green on the console, on the Amazon Web Services console, to actually log in. Okay. So we're going to pause right here. Everybody should be at this $sign. It should be something like Ubuntu at something something something, and then there should be a $sign, and it may or may not be colored, but everybody should be here before we continue. So Tiffany, let's do a check-in check in with me when the Windows and Linux folk are on. I'm going to go through the Windows stuff just very quickly for people that have that. Okay. So if you click on log into your instance with the Unix shell, log into your instance from a Windows machine, we have instructions over here, and essentially there's this MOVA extern software. Doesn't matter which one you download. You start a new session, and in that session you put in your remote host, which is your the name, that EC2 name, the username, which is Ubuntu, and then you click on Advanced SSH Settings. And now under SSH, you need to put in the use private key. And the private key here is going to be your Amazon key.pm file. It may have a .txt depending on whether you're using, depending on what web browser you're using. And once you have all that filled in, you click OK, and you should end up with basically the same screen that we have on the Mac and Linux, which is something that ends with a prompt that's Ubuntu at blah 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 colon $sign at the end. So once you're here, just hang out. You can go back through the screenshots, prepare any questions you may have, and we'll move forward as soon as I hear back from Tiffany.
I don't know.
Hey, Tiffany, just let me know if there's anything that I can help you with. I mean, don't worry about it if not.
Titus, we're all good here.
Great. How many people have given up?
All of them. No, I'm just kidding.
Victory!
I don't think anyone's given up yet. We're not letting them. We're not letting them leave the room. So
Excellent.
does that
Good.
count?
Good. Yeah. Lock the doors. Yeah. So I always like to say that this is the hardest bit, getting to log in, because it involves your local laptop. And after this, it can all be copy paste, and it's all concepts. So that may be challenging, but it's not like, well, this just isn't working. Now it's the usual Unix confusion. Which we can argue whether that's good or bad, but at least it's okay. So a couple quick things before we move on. I just wanted to say, what's the first? There's usually a first question in everybody's mind at this point. Anybody want to voice the first question in their mind?
How do I get root?
Well, okay. Conveniently, it tells you that. It tells you that on the screen, which is you run sudo. So we'll get to that in a second. But that is not usually the very first question. Sorry. You are a ringer, sir. Okay, how much is this costing me? Right. Yes. Okay. So I just want to show you. So we are running a dedicated instance of, I think it was m4.large is what I'm running. And I don't even bother keeping the links around because you can just Google them. If you go to EC2 pricing, let me see if I can find it. On-demand instance prices are for the US West, North California region, for m4.large are 14 cents per hour. So every hour from the moment we click that launch that we use this, we get charged 14 cents. If it's 61 minutes, you get charged 28 cents. And that's basically it.
Is there a way to help from your dashboard? Like, is it how?
So there have been inconsistent reporting that when you go to your dashboard, it may not always be updated in real time. So some things may have up to a 24-hour delay in reporting. There are also ways to set alarms. So actually, that's probably what I should start the class with, is like set an alarm. So if you go over $5, you get an email. But yeah, basically you can go and you get near real time, and it only charges you once a month, which I think is mostly good.
And the way to get there is what, your username drop down to billing or something?
Yeah. So if you go to billing and cost management, in my case, my account is actually paid for by one of my other accounts. It's complicated. Actually, no. In this case, I think this one's a direct bill. And yeah, so I have a spend summary, and my spend summary for March is $21. and its forecast based on how much I've used it while preparing this for this lesson is that it's going to be a $200 month. So last month I ran a workshop where a lot of people used my account, and so we spent $250.
We have a question.
Okay, there's a question on the Etherpad.
Is the billable time clock time? Do you get billed by CPU time, or are there idle charges?
Ah, thank you. The billable time is clock time. It is not CPU time. So the number of CPUs and so on is factored into the price per clock hour. So there's no, and it's idle or not. If your instance is dedicated and it's isolated, so they're not sharing. This isn't quite true, but they're not sharing your CPU time with other people, which is what a lot of hosting companies do. That CPU time is yours and yours alone. The reason it's not 100% true is because if it is possible for other people's usage of the machine that you're on, the actual physical machine in the physical warehouse that you're on, to impact your usage via things like disk. Like if somebody else is doing a lot of disk writes, then your disk writes may be impacted. But in general, it has not been a huge source of variation for me because I don't do this on a large scale. So it's actually, in some ways, it's better than some of the hosting services where they charge you a low price, but then they get angry if you use a lot of memory or a lot of CPU because you're impacting their other customers.
One thing to note about these, which I learned recently, is it's rounded up to the nearest hour.
It's rounded up, yeah. So 61 minutes,
right.
2 hours.
Right, or
yeah.
1 minute, 1 hour.
1 minute, 1 hour, 61 minutes, 2 hours. Yeah.
So,
okay.
A lot of 15-minute blocks.
Yeah, so on the flip side, and I'm no longer a graduate student, so my perspective has changed, but if you're worried about 14 cents an hour and that's a different kind of concern. What I would really be worried about in your place is leaving something running by accident or starting up 100 of them. Because now you're talking about $14 an hour if you start up 100 of them. Right? I did that math right. Yeah, okay. And that actually starts to get expensive. So when we're doing real research stuff, my Amazon bill for December was, for my lab's main account, was in the $1,000, $1,500 range. But I have a grant for that purpose. So, yeah. Okay. We can talk more about the funding stuff. Okay. So let's go back to, okay, there was another question which was about disk space. We'll get to persistence and disk space in a little bit. Save up those questions. But for now, we're going to actually do something with our brand spiffy new machine. I always like to stop and this is like 2016. It's a little hard to explain how super cool this is, right? There's some computer somewhere in the world that's completely at your bidding that you're renting via credit card. And yay, this is cool, right? Okay, a couple other notes. Your local systems administrator does not know you are doing this. That's generally for the better. So you can do whatever you want on these computers. There's no, it's good and bad, right? There's no restrictions on software you can install. There's no restrictions on what you can run. There's no restrictions on what you can have collaborators come and work on it. I have a colleague here at Davis that's talking with us about using this for research that where all his other compute resources are restricted by security clearance. But he has a lot of non-top secret or secret stuff that he's doing, and his collaborators in other countries can't get in to use his clearance required login, so he's starting up Amazon instances for the non-secure stuff. If you're doing anything that's secret, like at the level of actual secret legal problems will result, or has privacy concerns like HIPAA privacy concerns with human data in the US, you have to think carefully about how you use Amazon. There are ways to use it that are HIPAA compliant, but they depend on institution and use. And I'm happy to point you at those resources. UC Davis does have a HIPAA compliant access to Amazon EC2. So you can actually do human genomics computing on this. In Canada, my understanding is that you can't use EC2 for anything that involves human research because the Canadian government is all too well aware that the NSA has access to everything that's going on in Amazon. That having been said, I will just point out that two things. If you're uploading a bunch of your private research data and your concern is that somebody's going to steal your research data, just stop it. Nobody cares. Really nobody cares about your research. Like,
Except the IRB.
except the well, the IRB may care, but this doesn't actually violate. As long as you're not posting the data publicly, this doesn't violate. This is like buying a computer and putting on a computer and traveling with the computer.
That's fine, but they want to know that you have like
Right.
software font, foresight, whatever.
Yeah.
I mean, they're
Yeah. So there are issues around data access. The other thing is whenever people tell me that Amazon is problematic because of its security, I point out that the CIA has been using it for data mining for years. I'm not saying that's a win that argument, but at least it's something to think about, right? Like, is that things that matter more than your research are being done on Amazon. Anyway, okay. And I would also argue that Amazon sysadmins are likely to be, in general, are more likely to be on top of the latest security threats than at least my lab sysadmin would be necessarily, for example. So something to think about there. Okay, so let's go do something. So now I'm going to go back to the index of this page. Sorry, it is 216 Feb. Yes. And what we're going to do is install some software. We have two things we need to do actually. Let's start by configuring the network. This isn't as exciting as installing software, but basically by default when you boot a computer on Amazon. So this is under configure your instance firewall on the 216 Feb AWS website. So by default, when you start up an Amazon machine, it only allows logins via SSH, and that's it. There's no other access via the web or anything else allowed. You can't telnet in, you can't FTP in, you can't use it as a website. So, and that's because they have a default instance firewall that only allows in what's called port 22, which is the TCP port that SSH connects in on. If this is all mumbledygook to you, that's technobabble, that's totally okay, don't worry about it. We're just going to have to do some more technobabble to do the RStudio server thing. So what you should do is select security groups. So find your instance that's running, click on it, and then in this little pane that shows up below, you'll see information pane, you'll see security groups on the lower right. And you should see something like Launch Wizard 5. It may be Launch Wizard 1 or Launch Wizard 2. These are automatically created security groups that are created by default when you go through the launch thing that we did. You can actually configure one of these and select it every time you launch a new instance if you want. But I try to minimize the amount of stuff we have to do before getting to an instance. If you click on the security group, you won't see much of interest. Click on Inbound, and you should see SSH, TCP, port range 22, source 0.0.0/0. And what this rule means is allow SSH connections into this computer from anywhere. So what this means is allow SSH connections on port 22 in from anywhere in the world. The /0 at the end means that incoming computers need to match 0 bits of that 0.0.0.0 address in order to. You could easily restrict this to just UC Davis by selecting UC Davis's IP address range, but I usually don't bother. SSH is a pretty secure service, notwithstanding certain vulnerabilities that have been discovered in the last year. Okay, so what we want to do is edit this. So click on Edit, and we want to add a rule. Okay, quick note: if you change or remove the SSH rule, guess what's going to happen? I'll do it actually. I will change this rule. Don't follow along. I'm going to change this rule to port 80, and I'm going to save it. And all of a sudden, I don't know, you can't see what I'm doing. I'm trying to enter text in. My SSH connection has just stopped. Hasn't been killed, but no traffic is going back and forth between my computer and my Amazon computer. Conveniently, I can actually just fix that. And if I log back in, I'll be fine. So it updates in real time. So what we're going to do is we're going to edit and we're going to add a rule. It's going to be a custom TCP rule. We're going to use a port range of 8,000 to 9,000. The reason we've chosen that port range is that RStudio server comes up on port 8787, and they tell you that in the documentation. So that's how you figure out what the port range is. Or you just open all these ports, and most of our tutorials will work. Okay. And this is now a situation where, did it work? Okay. So you do edit, you add it, and then you have to click save on the lower right. And now you should see that you have SSH and a custom TCP rule. Okay? So now that we've done that, and all of these things there are screenshots for all of this. Now what we're going to do is actually install RStudio server. And we'll take a coffee break right after we get RStudio server up and running. Okay, so if you go back to that main page, click running RStudio server in the cloud. It has the instructions. First, start up an Amazon instance. Second, configure your network firewall. A quick note on configuring the firewall, you can do this while the computer's booting. So next time, if you start up a new computer, and while it's like still starting up and you haven't connected in via SSH, you can edit the firewall rules. Log in via the shell. Okay, at this point, we're at the shell. We're at the shell prompt on our remote computer. And the problem that we face now is that RStudio server is going to use an existing account name and password for the login. And you need to set a password, because right now our account on this instance doesn't have a password associated with it. This is a really insecure thing that we're about to do. I can explain that later. But for the purposes of the tutorial. Okay. So sudo password Ubuntu. What we're running is we're running as super user. That's what the sudo command does. We're running the command password, and we're running the command password on the account Ubuntu, and enter whatever password you want here. It won't show up when you type it in. It's hidden. It doesn't even give you little stars. And remember that password. You can always change it, but it'll be embarrassed. Like my short-term memory doesn't last more than 10 seconds, so. Okay. So now we're going to install R and a tool that RStudio server uses, which is called gdebi. And we're going to do that by copying and pasting this command here, sudo apt-get update and sudo apt-get -y install. So copy and paste that, and then just hit enter, and then wait a second. So here's the plus. So while this is running, the pluses and the minuses of this approach in general of using Amazon Web Services are that you get your own computer, you completely control it, you can kill it, you can upgrade it, you can stop it, you can install whatever you want on it. The problem is now you have to install whatever you want on it. So there's no systems administrator on call to do this stuff for you. Now, and it's a full Unix computer, so it's got all the complexity of whatever it would be if you started with a new Unix laptop or a new Unix workstation and wanted to install stuff on it. So there can be a lot of trickiness. The way I've overcome this in my own work life is I write tutorials for myself that have all the commands that I need to run to install something in particular. And that way, whenever I need to run a particular program, I just have a tutorial for it. You could also install all this stuff and then freeze the computer down, freeze the new installation down, and reuse it later on. The reason I don't do that is because as a professor, I do work so rarely that it's out of date. Like I might create something 4 months ago, and then 4 months later, like there's new versions of everything. So just writing down the commands to run, make sure that I get the latest version of everything when I'm installing it. And you can really do it either way, and it depends on your needs. If you have an active group of people in your lab or in your collaboration that's using it, it might be worth creating a frozen image so that everybody's starting on the same page. If you're publishing an analysis, I would suggest publishing the instructions and configuration you used rather than the actual machine image, because in 3 years, when people want to figure out what you were using, they may not, you know, that may not be the most useful description of things.
There's 2 questions.
Sure.
One is, can you upload an image of a system to Amazon? Which I think you just said.
So the question of can you upload an image to Amazon, and the answer is probably, but I never have. I wouldn't know how to do it. There's like complicated commands. I mean, that's how they get them there in the first place. But
usually it's easier if you start with a base image and then you install your stuff and then save it.
yeah, it's super easy to start. What Luis said for those on the microphone or remotely, it's super easy to start with a really minimal base image and then just install the stuff you need. Uploading it, starting from a blank image, an image that you create yourself is likely to be more annoying.
And the second one is, does Amazon keep the OS image patched and up to date security-wise, or is that the responsibility of the customer?
So for the you know, I don't actually know the answer.
Can you repeat it?
Okay, so the question was, does Amazon keep those images updated and patched? So the answer for the community AMIs is definitely not. The answer for the supported ones is I suspect they do if there's a major security hole.
But one of the issues that after you start your machine, they don't update at all. Like,
really good point. Okay, so if you go click on that like Ubuntu 14.04 thing that's not the community AMI on the front page, that won't start a new computer with any known security holes in it. If you started one a year ago and you've been running it for that entire time, or you've stopped it and now you're like spinning it up, and they're not going to go in and fix your running computer for really good reasons, right? So the last thing you want to do is have a running computer that was working yesterday and then Amazon was like, well, we fixed it, quote unquote, right? And one of the reasons you're using Amazon is to get away from that kind of thing, for better or for worse. So, make sense? Yeah, so one of the reasons I like starting with the Ubuntu 14.04 that's a long-term support line for Ubuntu, so they promised to support it with security patches through 2019. This one that I created right now, the 15.10, is, you know, I don't know who put it up there, maybe the official Ubuntu folk, but they're likely to upload a new one with security patches on it rather than fix this one. So in fact, I don't think they can fix this one because we refer to it via a specific AMI name. That having been said, the only thing that's installed on the server is SSH. So unless SSH or the Linux kernel are where there's security vulnerability, and that has happened, you don't have to worry too much about it as long as you use updated software. So in particular, if you look at the command we used, the sudo apt-get update updates the software catalog, and you can actually run a sudo apt-get upgrade that will upgrade all of the basic software to the latest versions if you want. And I should probably be teaching better practice on this than I am, but should I have them run sudo apt-get upgrade in general? Yes or no?
Yes.
Yes. Okay, I should. So what you should be running, and don't bother running it now because take your time, what you should probably be running is sudo apt-get upgrade. I'll run it and see what happens. So you can actually see upgrade. It upgrades the certificates, the Linux bootloader, glib, parts of glibc, the Linux headers, and the Linux kernel. I'm not actually going to upgrade this because I don't actually know what's going to happen. Yeah, those are all security vulnerabilities. So yeah, so we should totally be doing that. Anyway, so we're not going to though. And partly because who cares, right? What we're going to do is we're going to install some RStudio server stuff. We're going to run some stuff, and then we're going to kill the instance. And you know, at the end of the day, like nobody's going to be able to log in, break into this instance, and cost us money as long as we terminate the instance at the end of the tutorial. Okay, but I will make note of that for future. Yeah, okay. But that's actually why I don't like freezing down images, because then those security vulnerabilities won't get added back into the image. So, okay, so now we're going to download and install RStudio Server. And there's actually instructions, so while it's running, I just want to show you. At the very top, there's instructions for running RStudio Server on Ubuntu, and I basically just copied and pasted those instructions for this. Okay. Whoops, and I copied too much. So on success, you should see something like this, started RStudio Server. Okay? And now what we want to do is go visit the RStudio server, and for that you'll need your host name again, And the host name here is this EC2 thing. And if you go to that URL, your host name :8787, you should get a sign into RStudio page. And you have to put in username Ubuntu and password foo. In my case, now you all know what my super secret password is. You don't know how many O's I put in or use. And then do signed in, and I get the offer to save the password, which I don't want. And we now have, let me just change the password now that I've said it on YouTube. So this is now a running R environment. What's the quickest way to get an R plot up? Plot 1:10. And you can see it's a full RStudio server environment. So any questions at this point? Okay, one thing that, so it's the name of your computer, put it :8787. Okay, let me actually first check. Who could you just show me your hand if you've gotten to this point? Okay, so I'll just wait a minute before continuing. Are there any questions, local or remote?
I'm not going to be able to catch up with you. I'm going to have to go upstairs and generate a key pair and come back down. So.
Okay.
This is it.
Okay. But it is, I mean, the concepts are, I think, for...
Yeah. It's just it won't let me download a key pair here. Which kind of sucks. We do everything else.
Interesting. Okay.
Yeah.
It's a tablet?
Yeah, I have.
Oh, okay. Cool.
What is the username?
It's whatever, it's Ubuntu and whatever you set the password to when we were doing it in the command line before. Yeah.
There is also an RStudio AMI, no? Somewhere.
Probably. Yeah.
Yeah, there. Okay.
Yeah.
What's the advantage of it?
So the advantage, so the question is there's an RStudio AMI somewhere. So the advantage is that, I mean, the concepts are general, so you can do all of this with that as well. I tend to install a lot of software on my images for whatever I happen to be doing. So you could do that from the RStudio AMI, but I'm more comfortable doing it this way. So if you had, for example, your own Ubuntu set of requirements, you could also do this install on top of that and then have your sort of best of both worlds, if that makes sense. Yeah. No, there's no particular reason. I'm just going with what I know how to do, if that makes sense. Yeah.
So I installed one package.
Yeah.
It's going through, I mean, maybe it's dependencies or something, but it's just going and going and going.
Yep. Huh. Oh wow, it's actually compiling some stuff.
Yeah.
A lot. I don't know why that is. Oh, you installed stuff. Oh, I don't think this thing comes with most. So this is pretty much a blank Ubuntu machine, so it probably didn't come with a lot of the R.
Right, so you have to install whatever.
So you have to install whatever packages you want on top, yeah.
That's usually a quick process. That's usually.
It just depends on what's been preloaded, right? If it's a quick process on your computer, it's because you've already installed.
And also you're running the very small instance, right?
Yeah.
Like the network will be slow and the...
Yeah.
Oh, so it's just slow when you're running, yeah.
We're saying this is.
I think it's mostly compilation. Like,
yeah.
You're compiling source packages. And what our package should be installed?
Is that GG?
Yeah.
It's got like 10,000 dependencies. And
Yeah.
a bunch of them are.
So the reason to maybe use the RStudio AMI is I'm guessing it comes with ggplot and tplyr and a lot of the other common R packages already installed. Yeah. Okay. So I have one more thing to show you before we take a coffee break. Anybody have any questions though before we? Okay. So this is a place you can run your R code. It's a server that's as big as the server you chose. So if you use a micro, it's got a ½ gigabyte of memory. If you use a M4.large, it's got 8 gigabytes of memory and 2 processors. If you needed 200 gigabytes of memory, you could have that running too. It would just cost more. So the thing that really surprised me and that I think is super awesome about this is actually you can start long. This works the way you would expect it to, which is not always the way things actually work in real life. So if you had a long-running pipeline that took 12 hours to run, you could start running it here, and you could kill the window and come back in 12 hours, and everything would still be running, and you'd see all the output. So this is actually a pretty good solution. RStudio server in particular is actually a pretty good solution for running your long or compute-intensive R workflows not on your laptop, if that makes sense. So.
If you just click the shutdown button, and then just
you actually just you'd actually just close the connection, or just go home, close your laptop, go home, pick up. So I have done things where using Screen and Tmux, which are Unix programs for doing long-running tasks at the command line, I have done things where I've like started something at the airport, gotten on a plane, flown across country, gotten off the plane, reconnected, started up looked at my results, started up something new, gotten on another plane, gone and done something else, gone, like you can just sort of check in on your computing as you're running. So that's always fun. I did a lot of the work for my first senior author paper in a marine lab in France on Amazon, shutting it down. So it's really a very flexible system. Okay.
There's a question.
Yeah, question.
Can we run remote X Windows /X host over SSH from Amazon server?
Yes. So the question is, can you run remote X Windows? And the answer is yes in a couple ways. One is that if you're using MOBA Xterm, it actually already sets up that connection. MOBA Xterm actually comes with X Windows, is an X Windows server. So if you're running on Windows, you actually can view X Windows stuff directly. Everything else works as you'd expect. You have to have the stuff installed, and you have to have a local X server, and you have to SSH in with X Windows support, and then SSH will tunnel the X Windows stuff and all of that. And it works pretty much like with any remote Unix server. The disadvantage of that, in my view, is twofold. One is that you're running X Windows, you're running a graphical connection over a very long distance, over potentially a long distance, so it might be a little bit slow. And the other is that you can't detach and disconnect and go home and then pick up again. Right? X Windows has to have that always-on connection, unless you use something like VNC. And I can tell you more about that if you're interested. But there's ways to run an X server on your EC2 instance that then you can detach from and reconnect to. In general, I no longer use it. I can't remember the last time I used X Windows, but it is an option. Generally, I use notebooks like RStudio or Jupyter Notebook to do graphing and graphics now. Okay, so let's do something. Let's go back. We're going to take a coffee break. What we're going to do is stop this instance. We're not going to terminate it. We're going to stop it. So go up to Actions on your EC2 console. Go up to Actions. Go to Instance State. And click on Stop. Okay. And now there's a very important note. It says any data on the ephemeral storage of your instances will be lost. What that means is that anything that's not on your root file system on that image is going to go away. At the moment, most of us shouldn't have anything on anywhere else. In fact, if you do a df, that shows you what disks you have, there's only one physical disk attached. It's this XVDA1. It's your root file system. And that will stick around. That's the only thing that will stick around. If you had other disks, if you've done an M3.x large, for example, there will be like 40 or 80 gigabyte disks here. Those are going to be deleted when you stop the computer. Those are sort of and that's what they mean by ephemeral storage. So I will say two things. One is you do need to be careful. You do need to know where your data is and where your results are and what you want to save when you're using Amazon. But in 10 years now, 8 years of using this, I don't think I've ever actually, I've been a little bit paranoid, but I don't think I've ever actually lost the results of compute on Amazon, because it's usually pretty obvious. Like there's only like 3 rules, and I'll go through them, and it's usually really obvious what's going to happen when you do something. So, okay, so we're going to go back And we're going to do yes, stop. And then we are going to take, let's take a 15-minute coffee break. So 10:55, we'll be back. All right? Tiffany, are there any questions?
Yeah, let's pass. SFU, do you have any questions? Okay, so one question for later is why would you choose elastic block storage versus S3?
Yeah, perfect. Bookmark that question, and we'll cover it when we're doing storage.
Perfect.
All right.
Okay, we'll see you back at 10:55.
See you at 10:55.
So this is the end page.
Okay, we're just going to get started in a minute. We're waiting for some Keurig machine coffees to finish up.
Sounds good. We're ready to go whenever.
All right, we're going to get started. Okay, so everybody should be at their Amazon console, and they should have stopped up here. So this is the stopping your instance is the equivalent of basically closing your laptop. Whatever's running, I mean, it's actually the equivalent of shutting your laptop down, sorry. Whatever's running stops. Your data is still there, at least the data that's on your root drive and any persistent volumes, not your ephemeral storage. And sorry, that's a complicated. We'll get to what all that means in a second. But basically, the stuff we installed, of importance right now, the stuff we installed is all still there. And so we could start it up again, and RStudio server would actually be running and already installed, and we could just start using it. This is actually equivalent. Okay, so you could also have done a reboot. So the same menu has a instance state, and when you can reboot. Reboot will do the same thing, right? It'll shut down your computer, it'll restart it. Any running programs will stop. It's essentially like rebooting your laptop. The only difference between rebooting and stopping and starting, there are two differences. One is you get a new name. When you reboot, you don't get a new name. You keep the name you had. It's like the computer's still running, you just had a power cycle. When you stop it, Amazon throws away your ephemeral hard drives and your name, the name of your computer, and when you start it up again, you'll get a new name.
The public IP.
The public IP will change. We're not going to start it, though. That's too boring. What we're going to do is actually go down to image and create a new image. So before I do that, I just want to say, actually, let's go through that process, and then I'll show you what screenshots are. So what we're going to do now is we're going to create our own AMI that has everything that we installed already available on it, along with whatever files and data we put on it. So if we'd put an R script in, or uploaded a small data set or even a medium-sized data set onto that hard disk, that data set would be frozen down with the image. What the AMI freezing does is it takes the entire root file system and basically packages it up and bundles it as an AMI. So whatever you've installed and whatever you've uploaded is packaged. So one thing that this is potentially quite useful for is for classes. If you want to have if you have 50 undergrads or 50 grad students and you want to deliver the same installation of software and the same R scripts to them, you can put all the R script, all the software, all the R scripts, all the data on an Amazon computer, freeze it down to an image, and then make that image available to them, for one example.
But you were saying before that this is not like best practice.
So it depends. For classes like that, I think it's actually totally legit to be like, hey, we're running a workshop, we're running a tutorial, I'm going to create this image. Here's how you would install it were you to want to do that, but I've already done that for you just so we can get started, and here's the image. The big downside, and the reason software carpentry doesn't do this kind of thing, and you can go back in history if you want to see the long, I would say they weren't flame wars, they were polite, between me and Greg Wilson and others, is that The software carpentry MO is we want everything installed on your local laptop. For genomics stuff, with big data stuff, that's often not possible for the work I do. So that's why I do a lot of my teaching and training in the cloud, because if you need to distribute a 20 gigabyte data set, like that's not going to happen on most people's laptops. It also bypasses all the software installation tools. Anyway, so you can go either way. On Wednesday, for those of you that are taking the Jupyter workshop that, sorry, will only be at Davis, I'll show you yet another approach using my binder, where you don't even have to go through all this. You don't even have to pay for the compute, and we'll see how that goes. Okay, so click on select your stopped instance, go up to Actions, click on Image, and Create Image. And you have to give it one piece of information, image name, and for image name we're going to do Titus testing for workshop, whatever. You can name it whatever you want. Image description doesn't need to be filled in. I don't know what no reboot means, but there are these helpful little things. When enabled, it doesn't shut down the... Okay, don't worry about that. So what this is that you can actually create an image from a running instance. In this case, we've stopped the instance, and we're creating an image from a stopped instance, and that's very safe. If you create an instance from a running instance, you can get inconsistencies because you might be doing something while it's freezing it. Right, so you might get like a half frozen this and half frozen that. So that's what this no reboot thing does, is it doesn't shut down your instance. And then here's something that's kind of cool. You can say, I want to freeze it down with a bigger than 8 gigabyte disk drive. I want it to be 100 gigabytes, say. And that'll be the root file system. The only problem with this is that when you do this, I believe what it will do is it will allocate that much disk space for the AMI that you're creating, and you'll have to pay for storing that disk space on your account as long as you want that AMI to be available. So there ain't no such thing as a free lunch with Amazon. However you freeze something down, however you store something there, you're paying for it one way or the other. So and the reason they do that is because of gamesmanship, right? If I could have public AMIs that were arbitrarily large, then what I would do is put all of my data on a public AMI that was utterly unusable, and I would store it for free on Amazon. So there's actually how many of you know about the tiny URL? Sorry, total digression, but you know the tiny URL service where you can take a long HTTP URL and it will scrunch it down and like make it a short one? People have used that to store their MP3s and their data, because what they do is they encode the data as a URL, and they get the tiny URL service to freeze it down to a small URL, and when they want to recover the data, they just use the un-URL tangler. So that's the sort of thing you have to deal with if you're like, hey, everybody, come use my web service for free. People are like, great, how can we best take advantage of you? So anyway, there's probably like some really good ecology studies that could be done. Okay, so we're not going to change anything. I'm just going to do Titus testing for workshop, and then there's going to be this create image down here. If you click on that, and now it's going to say, okay, it's creating. And if you want to see where it's creating it, you go over to AMIs, and you can see that it's pending. And I don't know how long this will take. It's a very small image, but basically what it has to do is it has to save the disk somewhere. Okay, while it's doing this, I want to show you a couple things. If you look at permissions here, there's modify image permissions. You can actually make this public by clicking the public button, and that would then become a community AMI that people could search for. Right, so that's how people create community AMIs. You can also ask people for the AWS account number. So one of the things that we did early on in my lab, not with these, actually with snapshots, which I'll show you in a sec, is we would put multi-gigabyte data sets up and then share them with each other on Amazon, because that's what we were doing a lot of our compute. And it's a very safe way to share data because people have read-only access to your data. So they can make a copy of it and work on it, but they can't modify the originals, which if you think about it, if you think about most of your collaborators, do you really want them modifying your data files? No. Okay, so I don't know how long this is going to take. So let's go back to the instances while it's going. Let's go back to the instances, and let's spin this one up again. So to do that, click on it, go up to Actions, do Instance State Start, and say Yes. And now we'll go through the process that we went through before, but we've already configured it, right? We've already said how big we want it to be. We've already have the AMI. We've already installed some stuff on it. So now it's just going to start up with the default m4.xlarge or micro instance that you've been using. And it's now too late to do this, but if you wanted to change the instance type, you could go to when it was stopped, you could go to Instance Settings, change instance type. You could say, oh, I actually need more memory, or I need less memory, or I need more compute, or I need less compute. So you can do that sort of on the fly. You have to shut it down because it's not like you can it's like closing your laptop, taking out your laptop's hard drive, and putting it in a new laptop that's bigger or smaller. So it's a little traumatic for the compute.
Can I just get my head organized?
Yeah, please.
So you create an image and an instance. You say install all the packages that you commonly use in RStudio, and then you freeze that. And then whenever, since those are your tools, then you launch that when you need it.
Yeah. So let me just
paying a little tiny bit to store that.
Let me just repeat that for the benefit of the microphone. Yeah. So what we've done is we spin up an instance, we install the software and stuff that we want on the instance for our own purposes, and then we can freeze that down into an AMI. We can freeze that running instance down into an AMI that we can then save for our own or for other people's uses.
And then we can launch that with any number of cores and memory.
Yeah. So actually, I'm going to show you this. You don't need to do this unless you want to follow along. It gets confusing once you have multiple machines, but my AMI is now available, and I can select it, and I can click on Launch, and now it's going to ask me what size computer I want, and I can make it an M4.large, and I can launch it, and it's basically the same set of windows that I went through when I was launching the other community AMI, but now it's a private AMI that only I have access to, and I click Launch Instance. And now you will see on the instance screen that I have two. I have one that's this M4.large that's when we actually froze down, and there's this other one that's M4.large. And when the only way you know what it's running is if you scroll down in the little info pane, you can see that it is using, where's the AMI? Sorry. It's like right at the top, right? I'm just missing it. There's somewhere, oh, here. If I click on this, you can see that the AMI that it's using is this Titus Testing for Workshops. Sorry, in the lower right, as opposed to this one where the AMI that I'm using is this Ubuntu Wiley. I know you can't see that, but trust me when I say it's there. You can look at the YouTube video.
It's like a 1 minute delay.
Yeah. But anyway, so does that,
for the 8 GB image, is it free to store?
Okay, so then there was this question of, okay, how big is this, and do I need to? What am I paying? And the answer is that, where is it? I don't remember. I think where you see how much it costs is here we are. Okay. So this gets confusing, and I apologize, but when you create an AMI, what it's doing is basically it's making what's called a snapshot of the hard disk, and it's saving that snapshot. And the snapshot is actually under a different place over here. It's down under Elastic Block Store below Volumes. And here you can see the snapshot. The description is 8 GB in size. That's the size of the root disk that we froze down. You can see it's created by create image for AMI blah, 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 from blah, 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 blah. And that you're paying for. So for the AMI here, this is associated with the snapshot. Sorry, my screen is getting a little wacky. This AMI here is associated with this snapshot, and what I'm paying for is the disk storage associated with the software that I installed, the operating system that I started with, and the software that I installed on top of it.
You might give us some sense of what that costs to store.
Yeah, I haven't kept up, but it's the storage per gigabyte was 10 cents a month, like a year or two ago. 10 cents a month a gigabyte. So basically, until you get into the tens of gigabytes range, and you keep it there for a long time, this is 80 cents a month to have this AMI. So I tend not to worry about that, but something to keep in mind. Is this sort of clear? Sorry, go on. Yeah.
Can you just repeat what's the rationale for creating an image and so on in the AMI instead of just having an instant close and start?
Yeah. So the reason you might want to create a personal AMI is if you have a complex set of software that you need to install that takes a long time, or that you want to make available to a lot of people, right? So if you're going to use this RStudio server with a particular set of packages, you might want to have it ready to go whenever you want it to.
But isn't this already the case with my instance?
So your instance, right? So your instance you can stop, and then it would be the same thing. But what you can't do with the instance, and I know all these jargon stuff. What you can't do with the instance is make more of the exact copies of them. So you can't install all your stuff and then say, well, now I want to run this workflow on 5 different data sets using the same base installation. I want to run it on 5 different instances. You can't clone that instance. You can start and stop it and use that one instance, but if you want to clone it, you have to go through this AMI phase or install 5 separate images.
So we'll be only interested in creating AMIs and images if we're restricted by our own computer and want to do this on multiple instances.
For example, yeah.
Okay.
Or for teaching purposes, or for, yeah. Okay. There are situations where it comes. I generally don't create images. I should say I don't create AMIs generally.
Can you see all the instances?
You can you have to shut them down and then yeah.
So you want to make the image that you have created to be available to a class. And then do people have to use the AWS to have access to
Yes. Yeah, so if you wanted to use this for a class, you'd have to have everybody in the class somehow connect in to AWS. And there's a couple ways to do that. You don't always have to create an account with a credit card associated, which sometimes can be problematic for students. There are ways to create restricted, it's called IAM, Integrated Authentication Management, which is what they actually recommend. You create restricted sub-accounts within your account that have individual usernames and passwords. The reason I tend not to do that is because I tend to be teaching people that will then go off and do whatever they're going to do, and they're not like under my thumb as undergraduates in a class. But yeah.
Can you repeat the name?
IAM, Integrated Authentication Management. Okay. So if I go back to my instances, you'll see that I actually have 2 instances here. The newer one, which I think is running RStudio server, and the old one. And let me just verify. I should be able to go to either one of these and go to 8787, except it's not going to work in one instance. Let's see, what did I change it to? Yeah, okay. Great. So, sorry, so it works. So here's an interesting thing. The previous RStudio session was abnormally terminated due to an unexpected crash. That's because what I did was I shut down the machine via the Amazon control panel. So it was basically like, all right, slam, you're dead, right? So it's the sort of thing where like you want to save your work, your files and stuff in the RStudio workspace before you stop the instance, just like you would on your laptop before you're shutting down your laptop. All right, so what else? Are there questions at this point? So tell you what, I'm at the risk of confusing you more. I'm going to introduce more stuff, and I think that might actually clarify the image thing a little bit. We'll see. This is a theory, so we can test it. So okay, so I didn't have time to create a nice diagram of this, but there's really 3 types of disk storage that you can attach to a computer in Amazon instance. There's the operating system disk, or the root disk, which is what we've been using so far. There's ephemeral storage. And ephemeral storage, oh, sorry, before I go, I'm going to kill one of these 2 because I'm not using both of them, right? So to do that, you go to Actions, Instance State, and Terminate. And that will get rid of one of the 2 machines. While I'm showing you this, there's another thing that I use a fair bit, which is Actions Launch More Like This. So remember how we had to go through and pick an AMI and pick a size and pick a security group and blah, 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 blah. If you just like, look, I'm happy with this computer, but I want another one, I can just go to launch more like this, and it basically says, okay, I'm happy to take your credit card. Click launch, right? So, so the most dangerous box in here is, I think is it instance details? Yeah, is instance details, where there's number of instances. So you can put a number larger than 1 in there if you like, and launch 5 computers. So, but then you're paying for that. So anyway, okay. So I've terminated one of the 2. I have the other one running. So there's, as I was saying, so there's 3 types of storage. There's the root storage, and the root storage is if you connect in. So there's a couple ways to look at what the root storage is. You can log in. Ubuntu. You can log in this way with SSH, with MobaXterm, or with SSH, and someday, I hope this works. Okay, which one is this? There we are. Okay, so it works. So there's probably better Unix commands for this, but if you said df-h, or just df, you'll see that there's only one named file system here, dev-xvda1. It's approximately 8 gigabytes in size. It's mounted on /, which tells you that it's the root file system, and that's this file system that's associated with the instance. If I stop the instance, that file system will stay around. If I terminate the instance, that file system will go away. If I freeze it into an AMI, whatever's on that root file system will be frozen into that will be baked into that AMI. And when I start up a new one, I will have access to it. Okay? So that's the only type of disk we've talked about so far. Okay. There's 2 other types of disk. One we haven't talked about yet. One we won't talk about actually. It's if you go to launch instance, and you go to, it doesn't matter what AMI you choose. If you go to like Ubuntu, it's the instance storage here. And many of the instances that Amazon recommends you use don't come with instance storage, but some of them do. If you create an M3.large, you get a temporary 32 gigabyte disk. And that will show up on your DF as /MNT. Mounted under /MNT, it'll be 32 gigabytes. It's something that you can use for the purpose of storing data or running commands or temporary data output or whatever. And when you stop that instance or terminate that instance, everything on that disk goes away.
So it's like an external hard drive that you're adding to
your... No. Yes, but no, because we're going to actually add a fake real external hard drive in a moment that persists. It's like there's no good analogy, because what it's really like is someone says, oh, I see you're spinning up a new computer. Here, have a hard drive. And then as soon as you turn that computer off, they're like, I want that hard drive back. Right? So it's not persistent. It's like scratch space. It's the equivalent of like something that just belongs to the computer while the computer's running, actually running. And it's factored into the price of the computer. So M3.large, which has a 32 gigabyte hard drive, is going to be more expensive than a computer that has the same specs but no hard drive.
So like if you need a lot of temporary files, like you said that when you're doing money calls or something and you get a lot of extra space, that's when you would do something like that.
Exactly, yeah. So if you have a lot of temporary files, stuff that you know you don't really care about. The disadvantage, again, is that if for whatever reason you terminate that instance by mistake, it's gone. So it gets expensive if you put stuff there. So instead of talking more about that, apparently best practice in Amazon world has been moving away from those. What I'm going to do instead is show you how to create and attach a persistent disk that you manage independently of the instance. Because that, you can make the decision whether you want to keep it or not, and it sticks around when you accidentally or intentionally terminate the instance. And it only goes away when you hit delete. So. And then afterwards, as soon as we go through that, then somebody should ask me what the difference between S3 and EBS is. Okay, so let's go back to the, I'm just going to click cancel here. Let's go back here. So we're going to explore a new part of the sidebar here, which is this elastic block store here on the left, which is volumes. And I should say, before I go into this more, let me show you on the website. You now have a little bit more vocabulary to appreciate all of this. So on the website that will be persistent, there's starting up an Amazon Web Services computer that goes all the way through starting up an instance. There's logging into your instance, which has screenshots of logging in. There's configuring your instance firewall, which has screenshots of how to actually set the network interfaces up so you can connect in with services. There's running RStudio server in the cloud, which has all the commands for starting RStudio server. There's terminating your instance here, which is how to kill an instance. And then there's what we're going to cover right now, which is working with persistent storage, volumes, and snapshots. And then at the end, I'll go through a brief discussion on a few different things just to bake it in. So working with persistent storage, volumes, and snapshots has all of the screenshots for what I'm about to do. But as usual, I'm going to just go through it and talk through it, and then you can go back to the screenshots as you. OK. So the first thing you need to do before actually creating a volume is figure out what zone you need. And zone is now, it's like if you think of the region as the warehouse where you're running your compute, the zone is the room within the warehouse where they can connect hard disks and computers together. And to figure that out, you actually need to go to your instance information panel, click on the instance you're going to want to attach your storage to, and then scroll down a little bit and look for the availability zone. And so there's this cute little text. Availability zones are distinct locations within a region that are engineered to be insulated from failures in other availability zones. This is a nice way of saying that if a meteor hits availability zone US1B, US1C should not be affected unless it's too close, or if a power outage hits, or whatever. Companies care about this a great deal. Like Netflix runs almost all of their operations off of Amazon, and they know that you really want to be able to keep watching your Netflix shows, even if like Virginia gets wiped out. So they will have automatic resiliency between regions and zones within regions to make sure that you get your Netflix fix. We care less about this at our scale. I just want a computer that runs. So at this point, it's just a detail of things. And the important bit is you can only connect a computer you can only connect a hard drive to a computer within the same availability zone. So in my case, might be different in your case. In my case, the computer that I'm running, and I'm going to name it Herman. The computer that I'm running, which I've just named Herman, is running in US1C, US West 1C. I go down to volumes, and I say, I want to create a volume. There's already one volume there. This is the root file system for Herman, for the computer, the instance that I'm running. This is the 8 GB file system. This is what's called a volume. It's a disk that is around while I'm running that instance, and it will go away when I terminate the instance. I want.
Your name worked.
What?
You have to click on the check mark after you type in the name.
So my name worked fine
Oh.
because it's my instance name.
Okay. I was just looking.
The volume name I haven't set yet. And I will set it to Herman's root disk. Okay? Nobody else sees these names. That's just for your own. It's just for your own reference. Okay.
Curtis, why would you terminate it instead of just stopping an instance?
Because if you stop an instance, you're going to pay for that 8 GB volume indefinitely. And sometimes you're done. You're like, I don't need this instance anymore. I'm good. Okay. So what we're going to do is we're going to create a volume, and there's all sorts of options, and you can fiddle with them to your heart's content. The main two important ones are the size. We're going to create a 100 GB volume, and the availability zone, which needs to be changed in my case to US1C, and in your case needs to be whatever zone, whatever availability zone your instance is running in. And again, if you need help finding that, we can help you. But, okay? You can also encrypt this volume, and then there are other things you can do. So I'm going to click on Create. I think that you have options. You can make it a magnetic disk, or a general purpose, or a super fast provision network disk. And we can talk about those later. So if you click Create, what it's going to do is, this is my data disk. What it's going to do is it's going to actually go out, and you can't see the status here. Oh, it's already available. It goes out, it creates a 100 gigabyte hard drive, and it makes it available. That's what the blue thing on the right side means. And then you go up to Actions, and you do Attach Volume. And when you click on Attach Volume, if you go into the instance ID, you'll actually get a list of instances running in that availability zone. If you don't have anything here, it's because you probably created it in the wrong availability zone. So it'll only show instances that it can actually attach to. And when I click on this, it'll actually automatically fill in the device. And this is the device, for those of you that are Unix knowledgeable, this is what's called the block device name that inside Unix you'll refer to this 100 gig hard drive as. And you can just go with whatever it defaults to. Okay, and then click Attach, and now what you'll see is that this is now in use. So the little thing on the right will go from blue available to green in use. And what that means is, so that means it's attached to a running instance, and you can't attach it to a different instance until you detach it from this running instance. So these are disks. Literally what you're doing is you're like pulling a hard disk off the shelf, plugging it in to the power, and plugging it into the computer. That's what we've just done. The create was pulling it off the shelf. The attach was plugging it into the computer. You cannot have multiple computers attached to the same volume this way. You have to do something else like NFS or something more complicated. And that's one of the differences between using S3 and EBS, is that if you use S3, you can download the data from S3 to many different computers or attach many computers to the same S3 store because of the way it works. But here it's like I have a hard disk and I plugged it into one computer. Okay, but the fun's not over yet. We have a 100 gigabyte hard disk, but this is Unix. It's never as simple as plugging something in. So what we need to do is actually go to the instructions and go down to part 7 of the volumes and snapshots. And let's look at the computer that we've just attached to. So if we type lsblk, this is listing the block devices. I always like, every workshop I learn in a Unix command. So I have been a Unix sysadmin since like the early 90s. And I did not know about the lsblk command, probably because it didn't exist then. Probably it's new since then. I don't know. What this does is it lists all of the block devices that are attached. If you had created the volume but not attached to this computer, it wouldn't show up here. Only after you've attached the volume to the computer does it show up. And here you can see it's XVDF. It's not SDF because Unix. It's XVDF. Okay? And now what we need to do is we need to format and mount this disk. So we have 4 commands. The first one, sudo mkfs, makes a file system. It's essentially formatting the disk. The second command makes a mount point. In this case, I'm calling the mount point /disk. This will be the directory under which this disk will be available. The third command mounts that block device at that mount point. And the fourth command is technically unnecessary, but it lets me as a regular user write to this disk. Because by default, it belongs to root, and it's only writable by root for security reasons. And then, when you do a df, you will now see, actually, sorry, I should stop using df -k. If you do a df, you'll see how wonderful life is. You now have your original 8 gigabyte hard drive. You have another 100 gig hard drive attached to /disk. So any files or data that you put in /disk will be on this persistent hard drive. Clear so far? Ish? Clear-ish so far? Okay. Here's the magic thing. You can now terminate your instance, and this hard drive will remain around. So this is now where you can put your 80 gigabytes of FASTQ files, upload them once and leave them on this disk, and then just when you're doing compute, you would mount the disk and do stuff with it. Awesome. Excellent. I got a good awesome. Okay. So Tiffany, let's just check in on your side. Has everybody left now? Is the room empty? Are you just being polite?
The room is empty. Yeah, we're just being really polite. No, we're all good, I think. Any questions from this section, guys? Nope, we're good to keep going.
Okay, I decided not to do any activities in terms of like putting a file on this disk and then like showing you that the file's there, you know. But it works. This disk is persistent. You can put whatever you want on it. You can create multiple disks and attach them, and it'll just be XVDG, XVDH, XVD whatever. You can make them whatever size you want. I should probably make a note. You only do this MICFIS the first time, because this MICFIS formats the disk so it erases everything on the disk. So you only do that the first time. The makedir and mount are things that you would run every time you needed to attach this to a new computer. So if you could send me an email, I will go make sure that people know not to like, yeah. Also, if you try to mount a disk that you haven't done a MICFIS on, it won't let you. So it's actually safe to like first try to mount it and only then go, oh, well, I just created this volume. So. Okay. So a couple things. So if you want to, so suppose that a pattern that I indulge in fairly often is I will have a data disk, and I will have some data on it, and the data will be like my read-only archive of the data. So I will take the disk, I'll attach it, and then I'll copy the data off to work with it, and then I'll detach the disk. Because I'm paranoid, because I'm experienced, so I guess it's not paranoia, it's experience. And I don't leave my precious, precious raw data available for me to screw up, because I know that I'm the most likely person to screw it up, especially if I'm the only one that has access to it by definition. Anyway, so what I will do is I will attach a disk, I'll copy stuff off, and then I'll detach when I no longer need it. To detach it, what you need to do is make sure that there's no longer anything running that's using the disk. So if you try and do the detach command, it'll say disk target is busy, and you can't really see it. That's because I'm on the disk. If there's a program running that's using the disk, then it will say I can't detach the disk. So you need to leave the thing, and then you do sudo umount/disk, and now the disk is still attached, but it's no longer mounted. And you can go back to your EC2 management console, and you can do detach volume. If it's still mounted, it will not let you detach. You'll have to do what's called a force detach, and a force detach is basically the equivalent of pulling the USB plug out of the computer, and nobody likes, like, your operating system will yell at you, basically. I mean, Linux won't. Unix will be like, I'm sure they meant to do that. I will now crash. Okay, so that's how you unmount a disk. And again, it's right here. Okay, a couple notes on volumes. They remain attached when you reboot or stop an instance. So that attachment is between the volume and the instance, including the stopped version. And when you terminate an instance, they're automatically detached because there's nothing for them to be attached to, but they don't get deleted. So that's the important thing. All right. The last kind of disk that I wanted to show you about, and this is going to be really easy to show you, is just the concept of creating a snapshot. So volumes, and there's a couple of reasons you want to create a snapshot. Snapshots are what they sound like. They're essentially just single point in time copies of a volume, and they're read-only, which is brilliant.
So that sounds different than an instance. An instance is like a copy of your entire space, and not the volume, but
so
I mean image.
An image, yes.
Yeah.
So an image is something that comes with the associated execution information. So it's actually more than a disk. It may have multiple images. Can be much more complicated. They have multiple disks associated and other stuff. So an image is like, here's a disk that you can boot. And a volume is, here's a disk that you can attach. And a snapshot is, here's a read-only copy of a disk. And so the image uses the snapshots as a way to distribute the disks associated with an operating system. Think about it this way. A snapshot's a CD-ROM or a DVD that has, and an AMI is just a DVD that has an operating system installed on it. So you can boot off of it. Someday soon, I will no longer be able to use such terminology without getting blank looks from everybody in the audience. DVD, what the hell are you talking about? But yeah, so I don't know if that makes, there's a lot of different concepts, but yeah, it's, okay. So snapshots are awesome because you can put a bunch of data somewhere, you can freeze it into a snapshot, and that is now a backup of the data at that point in time when you made the snapshot. And there's two other reasons you might want to use snapshots. One is that they are zone independent, even though they're still tied to a region. So we're in US West. A snapshot can be shared with anybody in the US West region. But you have to make a volume from it in order to actually do anything with the data. So a snapshot's this like, basically the two things you can do with a snapshot are delete it or create a volume from it. And those are the only two things you can do with it. They're essentially opaque otherwise. They're not modifiable. So if you want to update a snapshot, what you do is create a volume from the snapshot, update it, create a new snapshot from that volume, and then delete the old one. And if you think about it, this is one of these things where, like, sorry if that's confusing, but this is one of these things where Amazon knows best. They know that if they gave you the ability to update a snapshot, you'd regret it. So they force you to go through the process of creating a read-only, of creating a read-write explicitly from a read-only, creating a read-write volume from a read-only snapshot, modifying the read-write volume, and making a new snapshot. So making a snapshot at this point should be pretty easy for you to do. You select the disk you want to make a snapshot of. You click on Actions. You click on Create Snapshot. It is generally a good idea to create a snapshot from a detached volume. Otherwise, it's the same problem where you could be in the middle of modifying it and you get a snapshot of a volume that's sort of in an inconsistent state. You create the snapshot, Titus's favorite demo snapshot of Herman's disk. I believe the description is public and the name is private. So the description will be something, if you make the snapshot available to other people, they will see the description to be able to search on it, I think. And it's not encrypted because we didn't have, the volume itself wasn't encrypted. You click on Create, and then you can go down to your snapshots, and what you'll see is that there's this 100 gigabyte snapshot that's pending because it takes a little while to freeze down a 100 gigabyte volume, potentially. And when you look at the snapshot, you'll now see that you will have the option of creating a volume from it. Right now it's grayed out because it's not available. And that's how you would create a read-write disk from this snapshot that would have a copy of whatever was on the snapshot. Right now our volume's empty, so this is a really uninspiring example, but it does work with lots of data. The other thing that I'd like to show you is, if I can, is there's also under Actions, there's also Modify Snapshot Permissions. And again, you can, just like with images, you can share your snapshot with other people using Amazon by entering their account number, or you can make it public. And so this is the way we've made some of our data sets public for people. As we've said, it's on Amazon. Here's my 100 gigabyte data set. It's on Amazon as this snapshot. Go have fun. Do whatever you want with it.
There's some questions.
Yeah, okay, so let's go through some questions.
Sure. Do you continue to pay for stopped instances while they are stopped?
So, do you continue to pay for stopped instances while they're stopped? You pay for their disk usage, but not their compute. So you pay at the standard disk rate. So if the image has an 8 gig root file system, you pay 80 cents a month for that stopped image.
Are you charged for snapshots that aren't mounted? Or are they considered data or an instance for billing purposes?
Volumes and snapshots are data, so they're counted at disk rates. Snapshots aren't mountable. The only thing you can do with a snapshot is create a volume from it, but you're still charged for the snapshot.
Okay, and then just why would you use elastic block storage versus S3?
Mm-hmm. Okay, so this gets tricky because there's no fundamental reason. So how would you store data on Amazon? There's a whole other service called S3, Simple Storage Service, Simple Storage Solution. I don't know. And what S3 lets you do, and I can actually just show you. It's something that I do also use. Let me just start up. You can actually go. It's actually very intuitive to use. You go to Storage and Content Delivery here on the left, I'm sort of curious what it's going to show. Okay, I don't have anything here. And what S3 does is it lets you create a bucket. So my bucket name will be dibtraining.ucdavis.edu test dibtraining whatever, and then you can specify a region and you create it. And this is now a place where you can actually put files. So I can now upload files. Let's see, if I go into this bucket, I can upload a file, and I don't know, what file would I want to upload? Do I have anything not dangerous? So here's a +1 paper, or here's actually a +1 figure, a PNG file, 35 KB, and I'll upload it. And when I go to the bucket, I think, I think that's, why can't I? Oh, I think now if I cancel, did I actually upload it? I think I should have uploaded it. Okay, apparently I didn't actually upload it. I usually upload things via the command line, so add file. Oh, you know what I bet's happening? Sorry, there's a start upload button on the lower right that I couldn't see on my screen. So I start upload, it uploads that file. This is now a PNG file that is available in my bucket. And here's the cool thing, a couple of cool things about this. One is, if I go to properties, I can make this public. I can say everyone can open and download this, and if I save that, this is now a file that has a URL, and the URL is right here, this link on the right, and this is a single file that has a name, and if I put this file at the bottom here, this is a file that if you load it in a web browser, it's actually the PNG file that I uploaded. So why is this cool? I mean, in some sense, this is basically like uploading something to Dropbox and getting a static link from it. It's basically exactly the same thing. You can do it with permissions so that only various people who have Amazon accounts can access it, and so on and so forth. The difference between this and EBS is that this file is something that can be downloaded without starting an instance. Volumes and snapshots can only be used, they're Linux file systems, they're Unix file systems, they can only be used in the context of a running computer. But in the context of a running computer, they're far more efficient. What you can't do with this efficiently is create a file system from it and edit this file. If you had 20 gigabytes of FASTQ files on a file system, you would be able to edit, modify, update those files. On S3, it would be, I think it's technically possible, but it's not a good idea because it's just a different, I don't know how to explain it in any other ways other than it's a different paradigm of file storage. One's a block storage device, and one's basically a web URL. One's a bucket. And block storage devices permit random access, and that's what you use for large files and modifying large files. This is a way, this S3 is a way to distribute files. So this is actually how when we have a file, even a large data file that we want people to be able to use, I put them on S3 because then they can download them to their laptop or to their server or to an EC2 instance using a web download, wget or curl or something. So I think that was maybe too long-winded. I use both. I use volumes when I'm running an instance and I want to do some compute upon some data and I want that data to be persistent within that volume, within that instance. And I use S3 to distribute files to myself and other people.
Do you store on S3?
I do store on S3, yeah, mostly associated with public data sets. So what S3 does, and all of this costs money, so I don't want to be like, oh yeah, you should totally use S3. But what S3 is great for, you know, in the genomics world, there were about 5 to 10 years where people would host data sets on their lab website. And most lab websites aren't really good places to put 10 gigabyte FASTQ files. The computer dies, it wasn't backed up, so on and so forth. S3 is just available all the time, and if for whatever reason somebody wants to download, 100 different people want to download my data set at the same time, Amazon can handle it. My lab website may not be so lucky. So I use S3 to store, like if I'm teaching a large class or even a small class and I want to distribute 10 gigabyte files, S3 is a great way to do that. If I don't want to force people to go through starting up an instance and connecting and Unix and blah, 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 this and that. Just here's the URL, download it.
But do you store like for backup on S3?
I do not.
Your raw?
Yeah, so I would consider putting my raw files on S3 for backup. The reason I wouldn't do that with like FASTQ files that were private is because in order to use them on an instance, I would then have to download them. So I would generally put the large files that I want to use from a workflow on a snapshot, frankly, because the snapshots are pretty robust. And then when I wanted to use them, I would make a volume from that snapshot. I would use that volume, and then I'd delete the volume after I did that.
Question.
Yeah.
Do you ever use Amazon Glacier for long-term storage?
I haven't started using Amazon Glacier for long-term storage yet, but there are ways to file and forget on Amazon that are less expensive. I just haven't started. All right. So I know that got confusing, but hopefully at least there's all the screenshots and stuff, and you can play with stuff, and you can ask questions via email or on Twitter. What I wanted to finish with is while I was writing all of this stuff up, I wrote down a list of things to mention and discuss. Okay, and so these are. I'm happy to expand these as people ask questions. So when do disks go away? They never go away on reboot. Ephemeral disks go away on stop. AMI attached volumes, which we haven't talked about, go away on terminate. Attached volumes, where you've created the volume separately and attached it, don't go away ever unless you explicitly delete them. And snapshots, again, only go away when you explicitly delete them. So coming over here, I have this snapshot, this disk that I've made available, that's available, that I created. If I go to Actions and I delete that volume is now toast. If I go to Snapshots, you can see I have this 100 gigabyte snapshot. I can now, with this snapshot, either create a volume or I can delete it. Those are basically the two options I have. And I can also make it public. So I could make 100 gigabytes of data just publicly available for you all to create volumes from. Okay, any questions at this point? Yeah.
Forgive me if I just missed this, but so how do we move data between our computers and AWS?
Yeah, so I was trying to figure out how much to talk about the question of how to move data around. And the short answer is however you would normally move data between your computer and a remote Unix server. Right. So you can SCP it, you can, sorry, who was that? Who? Yeah, sorry, okay. Yeah, so you can SCP it. You can have it like if it's from a sequencing core. Most of the sequencing cores, you can. There's a URL that you can use with wget or curl. You can download directly from the sequencing core to the Amazon computer. However you would normally transfer data around. Usually via SCP or SFTP are the ways I transfer data around. The other thing, and this is the next question that you would probably have is, well, I have all my code. How would I get my code from my laptop to the remote computer back? And that's where version control is probably the right answer, because what you would tend to do is have your code in a version control on your local computer, push it to GitHub or Bitbucket, private repository, public repository, whatever, and then clone that to Amazon, edit, update, run things there, and then push those changes back to GitHub or Bitbucket, and then download it back to your local computer. And that's very easy with with RStudio, as you know, to do with RStudio's Git interaction.
Can does Jupyter work that way? Because Jupyter's local, right?
So Jupyter will run just fine on your remote computer.
It won't save.
And then you can download the notebook. You just download the notebook, yeah. And we'll actually be doing that on Wednesday. So the other thing you can do, and I am personally not a big fan of this, and I'm not a big fan for a very specific set of reasons, but is you can also install Dropbox on your EC2 instance. It's actually totally okay. You create a Dropbox folder. You start Dropbox. You can download and install Dropbox. It has a Dropbox folder. You copy things into your Dropbox folder. They appear on your local computer and vice versa. There's two big problems with this. One is that your Dropbox folder may be very large.
Titus, sorry to interrupt, but comically we have a fire alarm, so we're going to say goodbye at this point.
All right. Everybody terminate your instances. Jessica will send out an email saying that, but terminate your instances at some point, okay? Bye.
I'll text her that.
Escape the fire. Okay. So it's still being recorded. So,
yes.
So if your Dropbox folder is 100 gigabytes in size, and some people's are, then you need a big root disk, or you need to install Dropbox in such a way that it points at a different disk. Otherwise, yeah. The other thing is, if you use Dropbox a lot from the command line, if you use your Dropbox folder a lot from the command line, you know that you can catastrophically screw up your Dropbox folder very easily. I don't know if that, like, with RM and other things. And so the reason I'm not a big fan of Dropbox is because I have screwed up my Dropbox folder too many times on a remote computer. So you can do it. I can point you at instructions for doing it, but I wouldn't recommend it. It's better to have your data and your code be read-only from the context of where you're storing it until you decide to update, if that makes sense. Okay. You can also just SCP things around, but I always get confused at some point with SCP. So. Okay, what are you charged for? You're charged for a running instance at whatever the price rates for that instance are. Ephemeral storage and instance-specific storage is included within that. So if it says you get a 32 gig hard drive with the instance, while it's running, you get that 32 gig hard drive for free, or for whatever, the 15 cents an hour or whatever it is. When you stop an instance, you're charged at the disk space rates for the stop disk. So if you have an instance that's got an 8 gigabyte hard drive, and you stop it, and that 8 gigabyte hard drive sticks around, you get charged for 8 gigabytes at a prorated. When you create a volume, so when you create that 100 gigabyte volume, you're going to be charged $10 a month for that volume. It's not going to be $10 just because you created it. It's going to be prorated, so I don't know exactly if it's by hour or what, but basically by creating a 100 gigabyte volume for less than an hour or two, you're not being charged more than very much money. When you create a snapshot, you're charged for that snapshot until you delete it.
So volumes and snapshots are not included in
right. They're separate. Yeah. One way or another, the right way to think about all of this is one way or another you're paying for it. And the main thing is that you're being charged a lot more for a running computer than you are for a stopped computer or data that's just sitting around. There is one interesting I hope this doesn't confuse everybody. If you rent, you can rent a static IP address from Amazon, so that you never have to change that. And if you rent a static IP address, the only time, it's called an elastic IP, and I've never done it, but my understanding is that if you rent a static IP address, while you are not using it, you are charged for it. While you are using it, while you're running an instance, you're not charged for it. Does that make sense? So they want to discourage you from like renting 1,000 and using 1. Right, so I just thought it was entertaining. Okay. Okay. So something you should do before you leave here is go to your instance view, clear all your search filters. Anything that's running or stopped is costing you. Go to your volumes and your snapshots page after that. Anything that's there is costing you. So make sure there's nothing there if you don't want to be charged for it. Okay. And I'll show you how to do that in a second. And then the last comment is regions and zones. AMIs and snapshots are per region. So US West, like the California region, an AMI that you create in that region will be available to any other person within that region depending on the permissions. It will not be available in Virginia or in Oregon. It will only be available in Northern California. Right? This causes massive problems when you're running classes that are from people across the world, because they all have to be using the same region if you want to distribute the AMIs and snapshots. Volumes and instances are then actually per availability zone within a region. If the volume is within US West 1C, you can only access that volume from an instance within US West 1C. So, and that's so are there any questions at this point? Yeah.
Titus, on the costs.
Yeah.
A little higher up. One thing I want to point out is in many instances you are charged for the data transfer to and from.
Yeah. So I've never been bitten terribly hard by that because I don't spend. I tend to transfer 100 gigabytes once,
right,
and then leave it there.
Right.
But one thing, right.
If people are downloading it over and over again.
Right.
You can.
From S3. Yeah.
Yes.
So I can't find the transfer rate. Can you, Jessica? Can you just make a note to me to put in the data transfer stuff? So the thing you want to avoid doing is saying, oh well, I'm just going to use Amazon a little bit. I'm going to transfer my 100 gig data there, spend a day computing on it, and then transfer back the results and discard the data. Because every time you transfer the data, you're being charged something. I don't think it's a huge amount, but it starts like everything else. Like none of what we're talking about is that expensive unless you start really using it a lot, and then it can get expensive. I should say there are Amazon research grants where they will give you free compute. You can apply. Usually, I don't speak for them. I've gotten a few of the grants. Usually in the neighborhood of between $500 to $5,000. It's pretty much a no-brainer for them to. If you say this is what I'm doing, I've heard that they offer a lot of those because it doesn't really cost them that much, and they sucker you into their ecosystem, which is all good. So there's another question. Yeah.
I didn't understand with the S3 whether we can do the same thing, like mounting the volume and having it accessed from.
You can. Okay. So the question for the benefit of the microphone: can you mount volumes from S3? And the technical answer is yes, you can. There's ways to connect them via what's called fuse, which are user space file systems. But it's really inefficient. The danger in doing that is if you're used to working with large files. If you're used to working with files and you mount them in a particular way and you mount them that way, what's actually going on behind the scenes won't necessarily be what you think. So if you take a 2 gigabyte file and you edit something right in the middle of it, with Fuse and S3, it will transfer the entire file, make that edit, and then update the entire file. Whereas with the block file system, there are much more efficient ways where it can go into the middle of the file and just tweak that, I think. Should be the way it works. So right, it's one of these things. It's one of these things where any abstraction you put around S3 to make it look like a file system is going to be leaky and is going to mess you up in ways that belie the convenience. I don't know if that makes sense. So I don't like to talk about it because I know, we keep on trying to think about how to teach this stuff, right? Because Amazon's a great way to make data available to people and a great way to do at least repeatable computing and all of that. And S3 is a great place for things that you upload once and don't change, and that you want other people to be able to download. So that'd be the best way to put it. So there is no good way that I don't have recommendations if you have files that you change a lot that you want to make available that are large, right? If you're like, I have a data set that I'm constantly updating, and I want to make that available efficiently to everybody, and I'm updating it on a regular basis, I don't actually have solutions for that other than a website, basically. Although I would question other things about that scenario. Right. In genomics, luckily, most of our files are big and read-only. Here's your 100 gigabytes of FASTQ data. Have fun. Don't edit those files ever. Yeah?
When you are done with a large file and you don't want to touch it anymore, do you move it over to S3 and download onto something else for long-term storage since you don't use Glacier?
Mostly I just leave it on S3. So Glacier is good for what's called cold data, where you're not going to use it. Where the only reason it's there is because in 15 years you might get sued for something that's contained in the data, and for liability reasons or legal reasons you need that data around. And then it's okay to have it somewhere where it takes you a day to get it back. It's like putting a hard drive on the shelf, right? Except that hopefully Amazon Glacier is more reliable than that. S3 is where you want to put things that you access regularly but sporadically, which fits my definition of like semi-archival data. The right place to put all this stuff is actually an archival for publication data. The right stuff is really to put it in an archival service like Figshare or Data Dryad or other places that actually, or SRA, where there's actually an archival thing. Veselia is gone, but the Davis library might have something as well that you can, where you can store largest files for long periods of time.
So, CDL.
Right, the California Digital Library has the
Merit.
Merit.
Well, Merit is one of them, yes.
Right, data repository, for example. I think it's fair to say that for people that regularly create data sets that are larger than a couple gigabytes, there's no solution that I know of in a general sense. Although within the UC system, you can use Merit if you're willing to pay for it and fill out all the metadata fields. Which is surprisingly, like people generate, anyway, the whole different thing, but people generate like thousands of dollars worth of data and they're like, but I don't want to spend 15 minutes filling in the metadata fields. It's like, that's too much work. Interesting. All right, so I hope that was interesting. I wanted to mention one last thing, which is that we have been running regular data therapy sessions here from 3 to 5 p.m. on Wednesdays. Those are not scripted or anything. You can show up with random questions about, like, hey, can somebody walk me through this thing with AWS, and we will generally be able to help you. So feel free to come to those if you want to start. If you want to try out a workflow, get this stuff running, and you don't want to have to struggle through all of this on your own, feel free to come by those sessions. Maybe the Davis R users group will also be able to help as well. And then there's also the Hackers Within group on campus, which is starting to run things like this sort of help sessions as well. So most of what I really like about Amazon is that it's essentially Unix with all of the stuff about using and access and creating resources. There's a web GUI, whatever. And there's actually command line stuff. We could have done everything we did today via the command line. We would have had to install that. So you can actually, it's scriptable infrastructure as well. But then once you actually start working with it, it's all Unix. So it's all the stuff that you would have had to deal with, whether you were you or your sysadmin would have had to deal with if you were on a cluster or on a workstation in your lab or on a big laptop or whatever. So at the very least, it has the virtue of not being too strange in terms of the workflows that you're already using. So cool, thanks, and see you guys around.
Thank you.